Hi, this is Kumaravel, Assistant Professor ECE from RMD Engineering College. Today's topic we are going to discuss about array of n-isotropic source under broadside case. We know that what under broadside array we will have major lobe maxima which is perpendicular to the array axis. Okay. So now in this topic we are going to find direction of pattern maxima. So in order to find the pattern maxima of minor lobes, let us consider total electric field expression of an n-isotropic point source. So here we'll have Et equal to E naught sin n xi by 2 divided by sin xi by 2. So total electric field Et equal to E naught sin n xi by 2 divided by sin xi by 2, where here small n represent number of element in an array and xi represent total phase difference. Okay, then whereas E naught is electric field, so Et represent total electric field. So now let us proceed. So we need to find direction of pattern maxima of minor lobes. So in equation 1, so sin and xi by 2 is maximum when your numerator value is maximum value. So under the case that what your sin and xi by 2, so the denominator term should not be equal to 0. If it is equal to 0, so anything divided by 0 become indeterminate. Okay. So let us consider sin and xi by 2, sin and xi by 2, which is equal to maximum, because we need to find pattern maxima. So sin value, maximum value of sin function is 1. Okay, so now we need to find at what angles we will get 1. So could you remember? So if you consider a sinusoidal signal, okay, sinusoidal signal, it will have maximum value at what? 90 degree. So here it will be 2 sinusoid, which is nothing but pi by 2, again 3 pi by 2, 5 pi by 2, 7 pi by 2, so on. So now we can represent this as where n xi by 2 equal to plus or minus 2n plus 1 pi by 2. So when this n equal to 0, this will become what? Pi by 2. So we will get, so first maxima. When n equal to 1, n equal to 0 means pi by 2, first maxima. When n equal to 1, it will be 3 pi by 2. So here minus 1. Okay. So minus 1. Then n equal to 3. So we will get n equal to 3 means we will have 7 pi by 2, so on. Okay. Now let us rearrange this expression. So from this find xi. So if we need to find xi, then this 2 will go there, then this 2 and these 2 will get cancelled. Okay, so we will have xi equal to plus or minus 2n plus 1 pi divided by small n. We know that already, where xi equal to beta d cos theta plus alpha, whereas alpha is phase difference between two adjacent source. Okay. So now let us substitute equation 4 in substitute equation 4 in equation 3. Okay, instead of xi we can substitute equation 4. So we will get beta d cos theta maxima of minor lobes plus alpha equal to plus or minus 2n plus 1 pi by n. Okay, so now again if we need to rearrange this, so we can rearrange the above equation. So if we rearrange, we will have a cos theta maximum minor lobe equal to, first we will take this alpha to your right hand side, it will become plus or minus 2n plus 1 pi by n minus alpha. When this beta, if it goes to your right hand side, it will become 1 by beta d. Okay, so again we need to find the angle. So the angle of minor lobe maxima. Okay, therefore theta maxima of minor lobes equal to cos inverse of this factor. So now let us consider for broadside array where the alpha, that is phase difference between two adjacent sources, are 0, and we know that already, right? Beta is nothing but what? Beta equal to 2 pi by lambda. When we substitute alpha equal to 0, this term we can eliminate, and we can substitute beta equal to 2 pi by lambda, 2 pi divided by lambda. So now what happens here? Pi will get cancelled. Therefore, we will have theta maxima of minor lobe equal to cos inverse of. So pi get cancelled. So we will have 2n d. So this lambda will goes to the numerator. Okay. So plus or minus 2n plus 1 lambda divided by 2d into n. Now let us consider, okay. So small n is nothing but what? Number of element in an array. So let us consider n equal to 4. So let us consider 4 elements we have in an array. And d, small d is nothing but what? Distance between the element. Distance between the element here we consider to be half wavelength, lambda by 2. So when n equal to 4, d equal to lambda by 2. So when d equal to lambda by 2, what happened? So if you substitute d equal to lambda by 2, these two get cancelled. This lambda get cancelled. So we don't have d factor and d as well as 2. So we'll have n equal to 4. Therefore, the resultant theta maxima of minor lobe equal to cos inverse of plus or minus 2n plus 1 divided by 4. Okay. So now let's proceed. Let us substitute capital N equal to 1. So when capital N equal to 1, from the previous expression, if n equal to cos inverse of 3 by 4. Okay, cos inverse of 3 by plus or minus 3 by 4. So 3 by 4 is nothing but plus or minus 0.75. Okay, so now we need to find what is cos inverse of plus 0.75. Plus 0.75 is 41.4 degree, and cos inverse of minus 0.75 is 138.6 degree. Okay, so this is cos inverse of plus 0.75 is 41.4 degree, and similarly cos inverse of minus 0.75 is 138.6 degree. Similarly, the same value we have for minus 41.4 and minus 138.6. Therefore, from this what we understand is, so from the above resultant value or angle, so we will have what? 4 minor lobe maxima are at 41.4 degree, 138.6 degree, minus 41.4 degree, and minus 138.6 degree. So if we draw it in the pattern, so we know that what it is: a broadside array where your major lobe is along 90 degree and 270 degree, and 0 is along here, right, 0 degree and 180 degree. So here we considered 4 elemental array. So small n equal to 4. So 4 arrays we have considered, and distance between the two elements is lambda by 2. Okay. So now we have minor lobe maximas are at 41.4 degree, 41.4 degree, where these are the major lobes and these 4 are our minor lobes. Okay, so minor lobes are at 41.4 degree, minus 41.4 degree, 138.6 degree, and 138.6 degree. Okay, so now we need to find minor lobes minima. So now to find minor lobes minima, let's consider the same expression, equation 1. So total electric field equal to E naught equal to sin n xi by 2 divided by sin xi by 2. So now we need to find the minor lobe minima. Therefore, let us consider the numerator term sin n xi by 2 equal to 0. So when sin value is equal to 0, so we know the sinusoidal waveform. When sin value equal to 0 at an angle of 0, pi, 2 pi, so on. So we can write it as what? N xi by 2 equal to capital N pi plus or minus capital N pi. Okay. Now let us rearrange it in the similar manner what I did for previous case. Xi equal to N pi into 2 divided by small n. Same manner. We know that what? Xi equal to beta d cos theta, right, beta d cos theta minima of minor lobe plus alpha equal to plus or minus 2n pi divided by n. Okay, now rearrange it to find the theta minima of the minor lobe. So cos theta minima of minor lobe equal to 1 by beta d plus or minus 2n pi divided by n minus alpha. Okay, so now from this again, theta minimum minor lobe equal to cos inverse of 1 by beta d plus or minus 2n pi by n minus alpha. In this similar manner what we do our previous case. So let us consider for broadside array alpha equal to 0, and we know that beta equal to 2 pi by lambda. So we know if we substitute alpha equal to 0 and beta equal to 2 pi by lambda, okay, alpha equal to 0, this term will get eliminated. Beta equal to 2 pi divided by lambda, then these 2 pi will get cancelled. The resultant expression is theta minimum of minor lobe equal to cos inverse of n lambda divided by n into d. N lambda divided by small n into d. So now we need to substitute what is the value of capital N and small n and d. So let us substitute capital N equal to 1, okay, and small n equal to 4 and d equal to lambda by 2. So small n represent what? Number of element in an array, and d is the distance between the elements, right? Lambda by 2. So if we substitute all these values, right, so we will get the theta minima of minor lobe equal to cos inverse of plus or minus 1 by 2, which is nothing but cos inverse of plus or minus 0.5. We'll have cos inverse of plus or minus 0.5 at an angle of when cos inverse of plus 0.5 at 60 degree and minus 0.5 at 120 degree. Similarly, we will have the same values at minus 60 degree and minus 120 degree. Okay, so now let us substitute n equal to 2. Let us see what happens in the same expression. So when we substitute n equal to 2, lambda small n equal to 4 and d equal to lambda by 2. So now what happens? 2 into lambda divided by d equal to lambda by 2, n equal to 4, isn't it? So now this lambda get cancelled, these two, then these two get cancelled. We will have simply theta minimum of minor lobe is cos inverse of plus or minus 1. So cos inverse of plus 1 is 0 degree, minus 1 is 180 degree. Same we have for minus, so we cannot write minus 0 degree and minus 180 degree. Okay. So now let us plot radiation pattern. So in this radiation pattern, so previously we derived for minor lobe maxima. Now we can find minor lobe minimas are at plus 60 degree, plus 60 degree, minus 60 degree, plus 120 degree, minus 120 degree. Okay. So next the rest is 0 degree and 180 degree. But already it is minimum value only. So 0 degree and 180 degree. So when we substitute n equal to 3, let us see what happens. So in this expression, if we substitute n equal to 3, we will have cos inverse of plus or minus n equal to 3 lambda divided by d equal to lambda by 2 into 4. So this lambda get cancelled, these two, so here get cancelled. We will have cos inverse of 3 by 2, which is cos inverse of plus or minus 1.5, which is not practically possible because cos function value is maximum value is 1, so we cannot have more than 1. So n equal to 3, 4, 5, so on, it is not at all possible. Okay, thank you.